Volumetric mass density rho. It is the mass per unit volume, that is rho equals to m by v in elementary form, rho equal to dm by dv or dm equals to rho dv. Hence m equals to integration dm integration rho dv. It is used in the case of solid sphere, solid cylinder or any solid body. Find the potential energy of the solid sphere in the figure as shown in the figure. We have rho equals to m by v, so m equals to rho equals to m by 2 by 3 pi r cube, because the sphere has surface area 4 by 3 pi r cube. So hemisphere will have volume 4 by 3 pi r cube, the volume of the sphere. So half sphere have volume 2 by 3 pi r cube. Volume of elementary disk dv equal to pi r square into dy. Okay. Mass of elementary disk is equal to rho dv. 3m by 2 pi r cube into pi r square dy. This implies dm equals to 3m by 2 r cube into r square dy. Hence potential energy of element du equals to dm into gy. Dm equals to 3m by 2 r cube into r square equals to under root r square minus y square, or so 3m by 2 r square into under bracket r square minus y square dy into gy. Hence u equals to integration 0 to r du equal to 0 to r t 3 mg by 2 into r cube y into r square minus y square dy. Z square equals to r square minus y square. This implies 2z dz equal to 0 minus 2y dy, or y dy equal to minus z dz. When y equal to 0, z equals to r, and when y equals to r, z equals to 0. Hence u equals to 3 mg by 2 r cube integration r to 0 z square under bracket minus z by z dz equals to minus 3 mg by 2 r cube integration r to 0 zq by dz, zq into dz, minus 3 mg by 2 r cube into z 4 by 4 in the limit r to 0, 3 mg by 8 r cube under bracket 0 to the power 4 minus r to the power 4 equals to 3 mg into r to the power 4 by 8 r cube equals to 3 by 8 mgr. So potential energy of the semi-sphere is 3 by 8 mgr. Next, relation between potential energy and force or conservative force. We have du equals to minus dwc, that is change in potential energy equal to negative of work done by conservative force, equals to f vector dot dr vector. F vector is the conservative force. Or du equals to under minus of under bracket fxi cap plus fyj cap plus fj k cap dot under bracket dxi cap plus dyj j cap plus tz cap equals to minus of under bracket fx dx plus fy dy plus fz dz. Equation 1. Now from mathematics, if u is a function of x, y, z, that is u equals to u x, y, z, then total differentiation du equal to delta u by del x into dx plus delta u by del y into dy plus delta u by del z into dz. Equation 2. So from equation 1 and 2, del u by del x into dx plus del u by del y into dy plus del u by del z into dz equals to minus fx dx minus fy dy minus fz dz. Hence equating each term, del u by del x into dx equal to minus fx dx. This implies fx equals to minus del u by del x. Del u by del y dy equals to minus fy dy, fy equals to minus del y by dy. And del u by del z dz equals to minus z dz. This implies fy equal to minus del u by del z. Where del y del x, del y del y, del y del z and del y del z are partial differentiation. Again, f vector equals to minus of gradient u vector, where this is called del vector, delta x del y del x I cap plus del y del y j cap plus del y del z cap. This is delta and which is equal to like this, or also it is called gradient. Hence fx I cap plus fy j cap plus z cap equals to under bracket of minus of under bracket del y del x I cap plus del y j cap plus del y del z k cap into u equals to minus del u by del x into I cap minus del u by del y into j cap minus del u by del z into k cap. Hence fx equal to minus del u by del x, fy minus del u by del y, fz minus del u by del z. In radial form, f equals to minus du by dr. The potential energy of a conservative system is given by U equals to ax square minus bx, where a and b are positive constant. Find the force acting in the system. Solution. Fx equals to minus del u by del x, fx equal to minus del y del x square minus bx equals to minus of a into del x square by dx plus b into del x by del x equals to minus a into 2x plus b equals to b minus 2x Newton answer, or F equals to b minus 2ax Newton. Now work energy theorem. According to this theorem, work done by all forces, conservative or non-conservative, external or internal, acting on a body or a particle is equal to the change in kinetic energy of it. Hence, del W net equals to change in kinetic delta K equals to Kf minus Ki equals to 1 by 2 mvf square minus 1 by 2 mivi square. Let F1, F2 be the individual force acting on a particle. The resultant force F vector equals to F1 plus F2 plus dash, and the work done by the resultant force W equals to integration F vector dot dr vector. Integration of under bracket F vector plus F2 vector plus dash dot dr vector equals to integration F1 vector dot dr vector plus integration F2 vector dot dr vector plus dash, or W equals to W1 plus W2 plus W3 plus dash, where W1, W2 are the work done by force F1 and F2 on the particle. This work energy theorem can also be written as work done by the resultant force, which is also equal to the sum of work done by the individual force, is equal to the change in kinetic energy. If W net is greater than 0, then Kf minus Ki is greater than 0. This implies Kf is greater than Ki. Kf is final kinetic energy and Ki is initial kinetic energy. That is, kinetic energy will increase and so the speed of particle will increase. If W net is less than 0, that is total work done is less than 0, then Kf minus Ki is less than equal to 0, less than 0. This implies Kf minus Ki, Kf is less than Ki, that is final kinetic energy is less than initial kinetic energy. So kinetic energy will decrease and hence the speed will decrease. As the non-conservative force, this theorem is written as work done by all forces, including pseudo forces, equals to change in kinetic energy of the body in non-inertial frame. work done by all forces, that is including pseudo force. Change in kinetic energy of the body in non-inertial frame. An object of mass m is tied to a string of length L and a variable force F is applied on it, which brings the string gradually at angle theta with the vertical. Find the work done by the force F. Here it is shown a force is applied in the horizontal direction. In this case, three forces are acting on the object: tension T, weight mg, and applied force F. Using work energy theorem, that is total work done by all forces, W net equal to change in kinetic energy, or Wt plus Wmg plus Wf equal to 0. Since U equals to 0 and V equals to 0, initial kinetic energy equal to 0 and final kinetic energy also 0. Also, Wt equals to 0 as tension is always perpendicular to the displacement. And Wmg equal to minus mgh minus mgl into 1 minus cos theta. Using these in 1, 0 plus under bracket of minus mgl into under bracket 1 minus cos theta plus wf equal to 0. This implies wf equal to mgl into 1 minus cos theta. Next, a block is slowly hurled off the hill by a force F, which is always directed along the tangent to the trajectory. Find the work performed by the force. Four forces are acting on the body: normal force, applied force, friction force, and weight mg, as shown in the free body diagram. Weight mg, normal reaction, friction force, and the applied force. Now, from work energy theorem, W net equals to change in kinetic energy, that is W mg plus Wn plus Wf plus Wf equals to Kf minus Ki equals to 0, because final and initial kinetic energy is 0. Or W mg plus Wn plus Wf plus Wf equals to 0, 1. Here W mg equals to minus mgh. Work by conservative force independent of what, and Wn equal to 0 since n is always perpendicular to displacement at all points. Calculation of Wf, that is work done by friction force. F equals to mu n equal to mu mg cos theta, and dw equals to minus f ds minus mu mg into cos theta ds, or minus of mu mg into ds cos theta, minus of mu mg ds cos theta equals to dl. Hence wf equal to integration dwf equal to 0 to l minus mu mg dl minus mu mg l. Equation 4. Using equation 2, 3, 4 in 1, we get minus mg plus 0 plus wf plus minus mu mgl equals to 0. Hence work done wf equals to, that is work done by applied force equal to mg plus mu mgl. A block of mass m equals to 1 kg moving on a horizontal surface with a speed vi equals to 2 meter per second enters a rough patch ranging from x equals to 0.10 meter to x equal to 2.01 meter. The retarding force Fr on the block in this range is inversely proportional to x over this range. That is, Fr equals to minus k by x, or 0.1 meter is less than x equal to 2.01 meter, and equals to 0 when x is less than 0.1 meter and x is greater than 2.018. Where k equal to 0.51. What is the final kinetic energy and the speed of the block as it crosses this patch? From energy conservation, work done by all forces is equal to change in kinetic energy. Here Wn plus Wmg plus W frictional equals to Kf minus Ki, or W frictional equals to Kf minus Ki because Wn is equal to 0 and Wmg equal to 0. Hence Kf equals to Wfr plus Ki. Now Wfr equal to x equal to a to x equal to b fr dx, or equals to a to b minus k by x dx, or equals to minus k into integration a to b dx by ex equals to minus k and dx by x equal to log x. So a to b in the limit, or minus k log b minus log a equals to k into log a minus log b, or k equals to k log a by b, equation 2. Using 2 in 1, kf equals to ki plus log a by b. This implies 1 by 2 m vf square equals to 1 by 2 m vi square equal to k into log a by b, or vf square equal to vi square plus 2 k by m into log a by b. Hence vf is equal to under root vi square plus 2 k by m into log a by b. Log a, this is ln, this represents that the log is on the base e. xa equal to a equal to 0.1 meter and xb equal to b equal to 2.01 meter. Hence m equal to 1 kg, k equal to 0.50. Law of conservation of mechanical energy. Suppose only conservative internal forces operates between the parts of the system and the potential energy is defined corresponding to these forces. There are either no external forces on the work done, no forces, or the work done by them is 0. Then from work energy theorem, W all equal to 10 delta K equals to Kf minus Ki. This implies Wc equals to Kf minus Ai, because here W all equal to Wc, because here only conservative force is acting in the system. Again we know that Wc equals to minus delta U equals to minus of Uf minus Ui. So from 1 and 2, minus of Uf minus Ui equal to Kf minus Ki, or Ui minus Uf equal to Kf minus Ki. This implies Ui plus Ki equals to Uf plus Kf. The sum of the kinetic energy and the potential energy is called total mechanical energy, that is U plus K equals to E, where E is the total mechanical energy represented by E is the total, and U is the potential energy and K is the kinetic. Hence from 3, EI equals to EF. From 3, EI equals to EF, that is initial total mechanical energy equal to final total mechanical, that is total initial mechanical energy is equal to total final mechanical energy in this case. Thus the total mechanical energy of a system remains constant if the internal forces are conservative and any other external force do not work. This is called the principle of conservation of energy. We have W all equals to Kf minus Ki, Wc plus Wnc, that is conservative, non-conservative, plus W external, Kf minus Ki, and this is equal to minus of Uf minus Ui, Wnc plus W external equal to Kf minus Ki, or Wnc plus W external equal to Kf minus Ki plus Uf minus Ui, Kf plus Uf minus Ki plus Ui, or Wnc plus W external Ef minus Ei. Thus, if there are conservative force, non-conservative force and external forces operating within the system, and work done by them is not equal to 0, then work done by non-conservative force and the external force will be equal to the change in mechanical energy of the system. Wc plus Wnc plus W external equal to Kf minus Ki. Again, this implies Wnc plus W external equals to Kf minus Ki minus Wc, Kf minus Ki minus Uf minus Ui, or Kf minus Ki plus Uf minus Ui, or WNC plus W external KF plus UF minus KIU plus UI or EF minus EI. Thus, if there are conservative, non-conservative and external forces operating in the system and work done by them is not zero, then the work done by non-conservative force and external force in the external force is equal to change in total mechanical energy of the system. Total mechanical energy of the system. WC plus WNC plus W external KF minus KI, WNC plus W external KF minus KI minus WC or EF minus EI. If external force equals to 0, then WNC equal to EF minus EI. That is, if work done by external force is 0, then work done by non-conservative force will be change in total mechanical energy. Again, if WNC equal to 0, then W external equals to EF minus EI. Note 1, non-conservative force is friction, viscosity, air drag, etc. 2, in above all formula, conservative formula, the system consists of conservative force. Example, find average friction force to stop the car at a distance of L meter. Here WNC plus WNC plus W external equal to delta K. Here WMG, that is conservative force, that is work done by weight equal to 0, and WNC friction and W external equal to 0 because there is no external force acting at this car. Hence W friction will be 1 by 2 mv into Vf square minus 1 by 2 Vi square, that is final kinetic energy minus initial kinetic energy, or minus of FL equal to 0 minus 1 by 2 mv square, because if final kinetic energy is 0 and initial is this, and F is the force of friction, hence F equal to minus F equals to mv square by 12 equal to 40,000 Newton answer. Here W frictional will change in kinetic energy, that is Kf minus Ki equals to 0 minus 1 by 2 mv square, or mode of W friction 1 by 2 mv square. Find the speed of the projectile when it hits the ground. Here only gravitational force, conservative force is acting on the projectile. So from conservation of mechanical energy, EA equals to AB, that is mgl plus 1 by 2 mv square equal to 0 plus, this is the potential energy. EA plus EB matlab total mechanical energy at A equals to total mechanical energy at B. So mgl plus 1 by 2 mv square equals to 0 plus 1 by 2 mv dash square. This implies 2gl plus v square equals to v dash square, or v dash equal to under root 2gl plus v square. So we get under root 3300 answer. So this is the end of work energy theorem, and we will again see you in the next our lecture in ffbmd. Fermi, Franklin, Fresnel's, Becquerel, Maxwell's and Dirac. So goodbye and to you.